All right, let's just jump right in. What if I told you there's a hidden pattern, a kind of secret blueprint that connects pretty much everything we humans create? From the way you structure a sentence to the grand arc of a symphony, it seems our brains might be hardwired to follow one very specific, universal shape.
I mean, it's a huge question, right? Think about it. A simple sentence, a massive Beethoven symphony, and the totally bizarre story from a dream you had last night. They seem like they're from different planets. But we're about to explore a theory that says they're all born from the exact same process happening inside your head. And that process creates a shape that we all just instinctively get. It's the story arc. You know that feeling? A beginning, a buildup of tension, that peak moment, and then how it all comes back down. It's a pattern you see absolutely everywhere.
And this isn't some new idea. People have been talking about this classic five-part structure for centuries. I mean, we're talking Aristotle's Poetics, Freytag's Pyramid and drama. It's all there. Initiation, rising conflict, a big climax, falling action, and then the resolution. This isn't just a formula for summer blockbusters. It's like the basic grammar for how we make sense of the world.
Okay, but here's where it gets really wild. This arc, it might not just be a useful metaphor for writers. The theory we're digging into today says this is a physical process, a literal flow of energy moving across the landscape of your brain. So, welcome to the Brain Kinematics Model. The core idea is that these story arcs are tangible things, the result of something called neural strain flow. Just try to picture it as a wave of cognitive energy, traveling through different parts of your cortex and physically carving out the shape of your thoughts.
So where does this wave even begin? Well, the model says it all kicks off right here, in the parietal cortex. You can think of this as the object anchor. It's the part of your brain that grounds the thought, establishing the who or the what of the story, the characters, the place, the basic facts. It sets the whole stage.
Next up, that energy flows over to the temporal cortex. This is your action driver. This is where the verb lives, the doing part. It's what creates motion, conflict, and that classic rising tension that pulls you into a story.
And the final stop on this tour is the prefrontal cortex, the subject conductor. This is the big boss, the CEO of your brain. It takes all that rising tension, orchestrates the big climactic moment, and then guides everything back down toward a final, satisfying resolution. It figures out the why and wraps it all up. But here's a key detail. This isn't a simple one-way trip. This neural strain actually flows in a loop. It goes around and around through these three areas, and with each pass, the idea gets sharper, more detailed. It's like polishing a thought until it becomes a fully formed, coherent story. And get this, the model even has an explanation for basic grammar. Adjectives, the words we use to describe things, seem to physically reinforce the object and subject states. And adverbs, they literally turn up the volume on the action signals. It's like they're little neural strain amplifiers. Who knew? Okay, so we've got a physical process in the brain that creates an arc. That's already pretty cool. But you might want to buckle up because this is where the theory goes from interesting to absolutely mind-bending. It suggests these neural arcs map directly onto a ladder of mathematical equations from simple stories to quantum physics. So at the very bottom rung, you've got this simple parabola. Yeah, that U shape from high school math. Well, that's the mathematical blueprint for our simplest stories. A children's fable, a basic sentence. One clear rise, one peak, and one resolution. Simple. Let's go one step up the ladder. Now, the arc starts to repeat itself. This is the sine wave. Instead of just one hill, it's a whole series of predictable rolling waves. This is the math behind rhythm. Think of a poem or the repeating chorus in your favorite song. It's that same rise and fall, just on a loop. Climbing higher, we hit something called the wave packet. In physics, this isn't an endless wave. It's more like a little burst of energy, a self-contained package. And the artistic version of that? A single scene in a movie or one chapter in a book. It has its own little arc, but it's also a packet of meaning that moves the bigger story forward. And here's where it gets really intricate: superposition. This is the idea that you can have multiple waves, multiple storylines, all happening in the same space, at the same time, weaving in and out of each other. The artistic version is just incredible. It's a Bach fugue with all its interweaving melodies, or it's a massive epic with dozens of character arcs all running in parallel. Which brings us to the very top of the ladder, Schrödinger's equation, the bedrock of quantum mechanics. It doesn't describe one definite path, it describes a wave of all possible paths evolving over time. The analogy here is just profound. It's the grand structure of a whole symphony, or a complex novel, a universe of potential notes and plot twists that ultimately resolves into the one story we experience.
So this mathematical ladder gives us a powerful way to think about things. But let's be real. Our thoughts and stories are often way messier than one perfect hill, right? Real-world cognition is so much more complex.
That basic arc can get twisted into all sorts of wild shapes. You can get cyclic forms, like a theme that keeps popping up in a song. Spirals, where an argument builds on itself over and over. You even get fractal patterns, those crazy repeating structures you hear in a jazz solo. And of course, there are chaotic forms, that unresolved, tense feeling you get from a nightmare. So the big question is, how does our brain pull off all this complexity? Well, the theory says it all boils down to two basic functions. If we get these, we can understand the engine behind creativity. But it's also really important to see where this theory has its limits. Okay, function number 1, substitution. The easiest way to think about this is going deeper. It's a vertical exchange of information between the brain's layers. This is what lets us nest ideas inside of other ideas. It's where all the depth, the rich detail, and those wild fractal patterns come from. And function number 2 is transferring. So if substitution is about going deep, transferring is about moving forward. It's that horizontal flow of those stream packages across the cortex. This is what gives a story its momentum, its forward drive. It's the engine that keeps it all moving along. But we have to be intellectually honest here. This is a fascinating hypothesis, but it is not undisputed fact. The model might oversimplify how brain regions really work. And this whole neural strain idea, we can't actually measure it, at least not yet. Plus, not all cultures tell stories the same way. And there are other big theories out there that could also explain these patterns. Still, even with those caveats, the central idea is incredibly powerful. To think that all of these different forms of human expression, from a single word to a masterpiece painting, could basically be different solutions to the same fundamental process unfolding in our brains. And that leaves us with one last massive thought to chew on. If this model is even partly true, does it mean that all of human creativity, in all its wild and beautiful glory, is ultimately the solution to a single cosmic equation playing out in our own biology? Now that is something to ponder.